Hey everyone, this is your weekly episode of the Zephyr podcast, where we talk about all things Zephyr, embedded open source, lots of other cool stuff. I'm Benjamin, your co-host.
I'm Fabio, your other co-host.
Oh wow, you were distracted for a bit. I
Okay,
don't know about
sorry.
you, but I did like this week. I tried to clean my office because I have probably as you, uh, Fabio, tons of boards and sensors laying all over the place. So I dropped a box and started to grab some of the sensors I had laying around. And not so luckily for me, I guess the first I found was a sensor that was like completely forgotten I had. And I'm like, oh, I wanted to play with that one. It's a millimeter wave sensor, like one of those radar human presence detection sensors.
Cool.
Yeah, really, really cool. And I completely forgot. I probably had it for like a year. And the reason I had it was that I wanted to add support for it in Zephyr and play with it. And it's actually really cool. I don't know if you've played with those, but it's really impressive tech, actually.
I really wanted to play with one. I last year I did a couple of lights for the house, and yeah, I actually did want to put a human presence detector sensor on one. The problem is that the one I made are battery powered. I think I might have looked at the very one you have. Tell me more about it.
Yeah, yeah. I mean, switches are just so 2010, right? Like it's just it's the old. No, I mean, so I think it's the one I have is probably like $4, but the actual chip is only $2. Only the flavor I have. So it's an IC Legend S3K whatever. So the actual module I have also has a Bluetooth chip on it, and I guess yeah, I'll come back to it because it's actually quite interesting. But it's a yeah, it is a kind of like in the shape of an you have a weird antenna on it, and it's meant to scan for human presence in a range of I don't know, like 0 to 6 meters, something like that. And it exposes all the sensor data over UART, and you can calibrate like the sensitivity and so on, and can be like, okay, I want to ignore anything below 2 meters and further than 3, for example, and like things like that. Yeah, it's pretty straightforward to use, and you have again this UART interface, and in my case, the Bluetooth companionship was actually super helpful because you end up using your Android phone to have not only a fancy application where you can visualize all the charts and all the sensor data in real time, but that also allows you to reconfigure the module, like the UART speed, for example, like the UART baud rate. You can change from your phone. That's like super convenient. You don't have to. I mean, yes,
So,
changing, reconfiguring can be a pain if you don't even know like which speed you're supposed to be using in the first place and stuff like that, right?
but it is obviously only for testing, right? Then you're gonna write your driver that where you set everything with device tree, I
Yeah,
guess.
yeah, totally. The the driver that I ended up writing knows nothing about the Bluetooth interface. It only does UART, and right now it only cares about reading the sensor data. But I guess like eventually I will add support for the so-called custom attributes. I don't know if people are familiar with that part of the sensor API, but usually sensors you only like fetch and consume data from them on like dedicated channels. So in my case, like you have a distance channel, presence detection channel, and so on and so forth. But many sensors are actually also configurable. You want to change, like you have free fall detection on accelerometers and stuff like that. You want to change some threshold. So there is a whole, yeah, attribute set and get API in the sensor API, which would be relevant here.
Yeah, that is the mechanism that you use to abuse the sensor subsystem and make it work for anything, and it can be anything you want subsystem, which is a bit of a problem we have, right? If you squint enough, anything can look like a sensor. So yeah, but I have a question. Does it work through walls? Have you tried?
So I think it does. I think it depends. So my sensor, I mean, or that sensor is 24 gigahertz. I think they are, and so you probably know better than I do, but I think there are some that are more like 60, 90 gigahertz, and I think those are the ones who would go through walls better, or maybe that's the other way around. I'm not sure, but I think it's it may be able to have some. You will get some information and some readings even through walls, but I actually double checked against the data sheet of this particular sensor. They don't explicitly mention that it goes through walls, so it might require a different technology. But it's really, really cool. Like for only a couple bucks, you get this. You get distance, not only distance sensors, but you can actually like make up the difference between static and moving human targets. And so you can easily imagine that if you add 2, 3, 4, 5 sensors in the same room, you can actually do even more than just presence detection. You can maybe
see where they are.
Yeah, really.
Cool.
So yeah, I've put together a PR with the particular sensor, a new code sample, a shield. It was good fun.
I think I took a look at that pull request this morning. I think you really want to use the interrupt-based UART API for this.
Oh yeah, I guess that was my question back to you. I wasn't sure. It felt so. I this is an opportunity for everyone, including myself, to learn more about UART in Zephyr, I guess. But my impression was that since I don't really care about unsolicited responses from the sensor, and it's only me who poll the sensor, I didn't necessarily need the interrupt API. Plus, I wasn't sure. I felt like maybe on some boards they don't support interrupt-driven API, so I was like, let's make it more accessible, but maybe I was wrong. Tell me about it.
No, the problem is that a lot of UART controller don't really have much of a FIFO. They may hold only 1 byte. So as soon as they receive it, you need to get that byte off the receive buffer as fast as you can. Because otherwise you're going to lose the next one, and your sensor is likely going to burst a bunch of data. So if you pull it, you may be in a situation where while you're testing it with a single sample, everything works, but as soon as you add other stuff to the RTOS, it's not gonna.
Yeah, no, that makes sense, and especially and to your point, by default, the module is set to communicate at 250K bits per second, which is actually quite fast.
It's really fast.
Yeah.
No,
Because
really
it's
fast.
a bit. I mean, the protocol is a bit chatty, and there's like the frames are pretty large. So yeah, to your point, I guess, especially at that speed, maybe I have issues already that I didn't realize I have.
Yeah, and we might have some driver that only support polling, but it just means that they are in development. I can't see a UART controller not supporting interrupt mode, but it is fairly common for a new driver, for a new platform to be brought up with the UART just in polling mode. The shell can work with polling mode, but you wouldn't really use that in an RTOS. It's just too easy to trash data. The other interesting thing would be to understand the power consumption implication of this, because keeping a UART running means that you have to have the UART needs to poll the data continuously. So you're going to have a fast clock running on the CPU. It'd be interesting to know if there is a way for the CPU to shut the UART off, go in a low power mode, and then turn it on only when it needs to transfer the data. But anyway, good job. I want to play with this thing as well.
Yeah, and I mean, just like we did just now, I guess. This was a good way to dig a bit more into things like UART and stuff. I guess I will have a look, because again, I used polling because I saw some sensors and some drivers doing it this way, but maybe they're wrong, or maybe they're just like they need to be refreshed and updated, because they would have the same kind of issues that I possibly have with this
I think so.
one. But yeah, it was cool stuff. Okay, moving on from hardware to hardware again. Some updates from this week in the various like working groups and TSC and so on. We spent a bunch of time during the architecture working group discussing changes coming to device tree. Do you want to update us on that, Fabio?
Yeah, so there was a bit of noise from the architecture working group about a change that got introduced recently. So device tree has this a keyword called ranges, and it's used to remap an address set from a child to the parent. I'm sure this is very easy to follow from everyone. Anyway, you would use it for stuff like if you had a PCI device that can be mapped in different address spaces on the host CPU. You could have the child node for the individual devices under the bus, and then on the parent, the ranges thing allows translating the addresses from the child devices back into where they show up on the parent address space. Anyway, somebody figured out that we should use this for the flash partition, because in most of the CPU that we have, they are mapped on the host CPU because we have execute in place. So there's a bit of a discussion going on whether we want to do this or not. And the implication is that something had to change in the kconfig that then decide where the application is loaded in Flash. And there's a range of patches where, in some condition, flashing on of some devices using the code partition has been broken. So just something to be aware of. There is just some breakage that happened. It should be good now. Current head seems to be compiling and flashing correctly in all cases. And I guess some out of three architecture, like if you just have a board, it shouldn't be the case. But if you have an out of three SoC or some variant of it, you may need to add some ranges directive on the device tree for it to work correctly in the long term when we remove the workaround that has been introduced at this moment. It's a bit of a subtlety on device tree. I'm going to be honest, I didn't realize the full implication of this initially. But yeah, the device tree.
Yep. We will be linking to the GitHub issue where things are being discussed. But yeah, we thought it would be it was worth bringing to everyone's attention. Similarly, in the TSC meeting this week, an update worth sharing is that as we are planning a new and upcoming version of the Zephyr SDK, which, by the way, we probably need to define what is the Zephyr SDK, because I remember it took me a while personally to get my head around it. Like I was like, Zephyr itself is, it's an SDK. I use Zephyr to build stuff. Yeah, I guess. But what we call the Zephyr SDK is effectively the set of tool chains and also some host tools like pre-compiled and ready to use versions of OpenOCD and whatnot that are available for whatever is your OS of choice. So you're on the Mac and you want to build for an ESP32 whatever board, you will need an Extensa toolchain. You could find ways to source that yourself from your package manager or whatever, or you get it from the Zephyr project, and we sort of guarantee that it will work. And so we, did I forget anything, Fabio, about what?
No, that's it. Yeah, if you ever try to compile your own toolchain from source, it's a bit of a nightmare. So I think that part of the value that Zephyr provides is the fact that it comes with a set of toolchain that are tested and validated with the projects for multiple architecture, right? So no, this is this is good stuff.
Yeah, and so the change that's coming, but it's a news worth sharing, but I think it's to some extent a non-event because it's going to be extinct pretty soon. Support for macOS Intel platforms, and so I think Apple started to pull the plug already on starting to slow down, or even will stop providing updates altogether for Intel x86 flavors of MacBooks and whatnot. And so the flavor of the SDK targeting macOS Intel, we're having sort of difficulties keeping it running and maintaining it and making it available. So it will go away, and so people should be prepared. Yeah,
it's crazy, isn't it? It seems like it was just the other day when Apple switched to ARM for their laptop to me, but time flies. They did quite a few revision of the CPU, actually.
Yeah, well, isn't it M6 already that they are
Yeah.
launching anytime soon, or maybe M5. I'm not sure, but it goes. Yeah, it's been a
Apparently,
while.
something like that. So what are the implications of this? I guess obviously the oldest ticket. Like in case you still have you're still been building on macOS Intel, yeah, switch to Linux. Sorry, no. What I meant is it's probably gonna work for a while, but there's no guarantees, right?
Yeah. I think people who have Mac Intel platforms, they know that this is probably not the future. So things like
Well,
this will happen more and more. Like distros of whatever, like other tools will probably stop being available as well. Yeah.
very well.
So yeah, those were the updates. There's also an interesting blog post we spotted from Sean Imel, who's been really active. We will be, of course, sharing the link to the blog, but many of you listening may have seen his video series about Zephyr. He's blogging quite a bit, been creating lots of great content, and so he just wrote a great article about, I guess, partly based on his personal experience, the quote unquote hidden costs of using Zephyr, which, yeah, in just a few paragraphs, kind of like summarizes, I think, things we know to some extent with regards to the fact that Zephyr can be intimidating or surprising for maybe folks who come at it expecting it to be, oh yeah, this is an RTOS, it's going to be pretty simple, a couple of source files, I compile them, tweak them the way I want, and things will work. Yeah, maybe there's a bit more complexity in there, but that's, I think he highlights this really well. And the way I read the article, and we can go maybe through the main bullet points, or like the main things he's mentioning, but I think in general, he's basically saying Zephyr is great. It's a bit complex, but there's reasons for it. Just be prepared, I guess.
Yeah, so it was framed specifically for Zephyr, but it was really a reflection on doing embedded with a complex OS, including subsystems and driver and build system. So I think it was very reasonable, and it's like setting up the expectation. And then he also obviously plugged his 75-part tutorial series on developing with Zephyr that he did for DigiKey. Yeah, should we go through for the point? Just do a bit of comment, just a minimum reaction.
Yeah,
On the various
totally.
points. Yeah. So the steep initial learning curve. Yep. Good luck. We don't hear about that so much anymore, though, right?
Yes and no. I think it depends how you define steep learning curve. I think it's fine that people need to invest a bit of time when they learn a new platform. It just shouldn't be too much, right? And so as long as the expectations are set, and whether as long as you have sort of like the big picture and you know what you're signing up for, it should be fine to have some kind of learning curve. It's just wrong when it's too much, right?
Yeah, but I think that what changes that maybe people realize that you get a lot out of it. So it may be the perception of it's worth investing some time learning how to use this thing properly. It may be worth it. And the same goes for the point after, which is the complexity of the build system, which, yeah, it's a pain point, right? Like I try to avoid touching CMake anything any more than I can.
One thing that is mentioning is like, when you come from, say, Arduino style workflow, you will be like really surprised, and it will be overwhelming, all this complexity, and you will have to like picture yourself like what's the architecture of the thing under the hood. But the thing is, Arduino by design is probably also equally complex the way it's implemented, except that
underneath,
by design, I mean, the promise is that you don't care about it because it's more like a prototyping platform. You don't have to learn how the Arduino build system works, because why would you?
Right. And similarly to the next point, the debugging becomes more indirect because you have all the UI abstraction in the middle. And it's a thing, but again, it's equally a thing in many other, like compared to working bare metal. But You would still have the device. These days, on a reasonably complex MCU, you would still probably have the HAL to deal with. So yeah, it's obviously one more layer.
Yeah, and again, like Arduino, you probably wouldn't even think about debugging, because when you use Arduino for bringing up some idea to life, you just rely on like maybe more basic libraries, and they will likely just work for whatever you want to do, and you don't even have to debug. If you would have to debug, it might be a different story. Yeah. What else
What
was there?
else? Yeah, hidden resource overhead. Yep. On the other side, there's a lot of clever tricks to try and optimize it. So I'll tell you what, it could be a lot worse.
Yeah, I think the point he's making is like there's kind of this double-edged sword where everything in Zephyr is configurable. Like, and usually with like a really fine level of granularity, you have kconfig for pretty much everything with reasonable defaults most of the times, but sometimes maybe you don't realize it, but you're pulling in a feature that you don't really need, and this means, I mean, this is bloat in a sense, and this will make your application longer to compile and larger in size and more exposed to side effects and whatnot. And so you need to be, I guess you need to be aware of that. And but this goes both ways. This both flexibility, but also sometimes it can get
Yeah, and same. There's a point on integration friction with vendor ecosystem. Like if you have to integrate something, it may be harder, which is true. But also, but the opposite in some cases is true as well. And we've seen cases with this. For example, we spoke a few episodes ago about the OpenBMC project, where the guys just took some Linux application and they managed to port it to run on Zephyr easily, as far as they said. And something I didn't mention last episode with the switch that I found that is running Zephyr. I was trying to figure how the shell commands work, and I was just putting them on Gemini because I couldn't find any documentation because it's internal stuff. And it was spitting out a lot of the documentation for it. And what I realized is that these commands that were running on Zephyr in other version of this architecture used to run on Linux. And it was really, really obvious that the developers of this stuff, they just ported them over. And the way they ported it, it was fairly clear that they didn't really have to change that much, right? They just had to plug it in. So having stuff like POSIX means that some type of integration actually becomes really easy, right? Like I ported network stacks myself just for fun, and it just worked pretty much. It was pretty much only a matter of integrating the build system. So
Yeah, well, I guess I was about to say just that. Like, I think that the friction integration-wise might be, it's not really at the Zephyr source level. It's more in terms of like tools, and like if you're trying to you want to stick to Zephyr upstream for your development, but then your silicon vendor is trying to provide you with their own SDK and IDEs and whatnot, and then you might have to learn different different tools and stuff like that. But
right. Version churn. This is probably going to become better with time as things stabilizes.
Yeah, I think is making the point, and something that we actually discussed in the TSC meeting. Many of us are maybe biased in the way we do development upstream in Zephyr, and we sort of see only the tip of the main branch and use this as our reference. When you build an actual product, you probably want to do anything but that. You want to stick to maybe LTS, or at least to a major released version, because otherwise there's just too many things that will break under your feet, and like things that you don't have time to test, because there's dozens and dozens of commits making it every day. So yeah, I think is basically recommending people to stick to given Zephyr version for their development and things like that, which is great to read in a blog post. This is probably things that we need to maybe document better in the Zephyr documentation proper, like to just make sure that people, things like the getting started in Zephyr is like, yeah, you want to get started with Zephyr, go and leave off of main. Maybe we don't do that. I don't know. We shouldn't do that.
Yeah. All right, good reading. We're gonna link it in the show notes.
Yeah, and Sean, if you're listening, maybe we should do a tech talk or something, and we should go into more details and have you exchange live about your findings. But yeah, great stuff. Was nice to see this in the timeline. Let's switch gears to actual updates. Speaking of lots of commits making it into Zephyr, some areas that we typically don't talk about a lot or enough in the podcast, Bluetooth and networking saw quite a bit of changes this week. So let's start with networking. There is a new DNS browse command as in shell command.
Yeah, it's a shell command, really cool. So Peter wrote this one, so you can use it for service discovery. I didn't realize this stuff was using DNS. So if you have like Apple devices on your network, they tend to be fairly loud. And yeah, this is a shell command you can use for finding these kind of devices that are in the network and expose some service. And the way it works internally is that it uses DNS over multicast. Yeah, really cool thing to play with.
Yeah, and I think it's not necessarily limited to Apple devices. Like it can also be like you're on a network and you're like, I want an MQTT server, and like you can also use. I know that Mosquito supports this. You can discover an instance of an MQTT server / broker using DNSSD. Can be useful for local network discovery.
Yep.
So there's that. There is like really fresh off the press as we are recording this. I think the PR is from like an hour ago. Robert, one of the two maintainers from Nordic, is opening a PR to bring something that comes, I guess, from the Nordic ecosystem and is now becoming a Zephyr thing, an FTP client library, which we didn't have.
So retro.
Yeah, so retro. I guess FTP server might be next, and queue all the CVEs in the next few months as we open new. Or hopefully not. Obviously, I'm joking, but FTP is cool. I think for some like IoT scenarios, etc., it might make sense to be able to dump some large, synchronize some large files. Or whatever. It's shell module is going to be available, code sample, etc. So yeah, great to see this.
FTP is cool, only on the Zephyr weekly podcast. Macros are cool.
And the FTP shell module is already using the shell help macro that we've been talking about. And as a matter of fact, I think now all the network or networking shell commands, they have all been migrated, saving, and you've heard that story before, but saving a couple kilobytes of flash. If you care about using the shell commands, now they eat up way less space in your system.
This is very cool. I think we should fold back that structure in the shell command and break everybody's out of tree code. But if you don't do it, I will. You've heard it first. Okay.
Yeah. But I'm glad to see. For me, the main, saving flash is cool, but bringing more consistency as well. Like you have, and maybe this is a bit of an OCD thing, but having all the, like, you type help, and even if you have like dozens and dozens of commands, they all flow nicely, and you can parse through them more easily.
Yeah, but saving flash as well, right? If you look at the project mission, if I recall correctly, specifically mentioned developing a world-class RTOS for space-constrained devices. So we care about space constraint, right?
Of course, yeah. I guess some people would argue, I mean, you said that last week, like, you love to find shells in production products, but in practice, things like logging and shell, etc., it's better if they don't use a lot of flash, but they don't end up in the final product. Anyways, enough about shell.
Very cool. How do I know if a board that I'm using is actively maintained or not?
Yeah, so I think this sort of echoes some of what Sean is saying in the blog post. We hear a lot people complaining, or at least commenting on the fact that in Zephyr, it's not always easy to uh, gauge the level of maturity of a given driver. Is it actively maintained? Is it up to date? Should I trust it? Is it feature complete? Like, does it implement all the potential driver operations available for this category of device, etc., etc. So iterating on that, it's really pretty random to some extent, but I'm interested in people's feedback on it. In the documentation of the boards in Zephyr, now you will find a new like small note on the like next to where you have the fancy picture of the board. You have a note that tells you whether the board is actively maintained or not, and gives you a sense of, okay, I'm ST, NXP, Nordic, like all those boards will very obviously show up as being actively maintained. But those boards coming from AliExpress and or from vendors that have never committed to actively maintaining the boards, you will have a mention about it. Yeah, I guess
And
I think if I hear and understand correctly the feedback from people, this should help, and we could generalize this for drivers again and for other areas. But this helps give you a hint about this thing is
yeah, and the indication is derived from the maintainer file, right?
correct.
So it's automatic. Because my concern was when we add this kind of metadata to anything, it's who is going to maintain the metadata is going to
Yes.
go to
Yeah, no,
take.
it's
But
really based on like if someone signed up to be a maintainer of a given area and put a bunch of boards in that area, then the board is considered to be maintained, and you know that you have someone looking after it and hopefully testing it, etc. But yeah, again, this is just an indication to be taken with a grain of salt to some extent. But I think, I might actually try to do something similar for drivers at some point, as long as. Let's see. As always, interested in people's feedback in the comments on or join us on Discord. Tell us what you think, or any other ideas along the lines of surfacing this kind of information to users.
good stuff. Should we do some of the new boards?
Yeah, there's a few. So I think we spotted two at least that are noteworthy. One is from Alif Semiconductor. I'm actually quite happy this finally got merged. It took a while. I think Alif, they joined the project as members probably a year ago or so, and they were suddenly, one of the reasons was that they were interested in being more active and upstreaming some of the stuff in the project. And so, yeah, there is like that PR that got merged this week includes the support for their E8 SoCs and the associated developer kit. It looks like it's kind of a beast, right? And I don't think they need to bring up some of the peripherals still, like I2C, etc. But basic support is here. It's like it's quad core, is it?
Yeah, well, I think it's one of those boards that runs Linux on the application core and Zephyr on the secondary core. So it looks like it's a dual A32 and dual M55, and Zephyr is going to run on the two M55. Right, okay. Yeah, interesting board. So yeah, 64 meg of PS RAM, 128 meg of flash, speed USB, Ethernet, everything you expect. But it's probably the contribution is from Alif employees themselves. So we're probably going to see more. I checked their website; they have quite a few interesting devices. If you go on their website, they invested a lot on the AI marketing. So be ready.
Right. And yeah, like you said, it's from Alif. It's actually showing up as maintained. Like the new board is showing up as maintained in the documentation. And yeah, it even has a bunch of actually interesting sensors like accelerometers, etc. They are not yet supported, not because we don't have drivers in Zephyr, but just because, like I said, they still need to bring up I2C drivers and stuff like that. But yeah, it's really I'm really looking forward to see
That's cool.
the other contributions from them.
Good stuff. And the second one, it's not quite a board,
Mhm.
but it's the secondary core on some Max 32 SoC. This seems to be, these are some pretty beefy ones as well, right?
Yeah, so yeah, apparently, and that PR had been around for a couple months, but Analog Devices has so some of the Max 32 SoCs apparently have a RISC-V core, which I think you were telling me is used typically for Bluetooth, for running a
Yeah.
Bluetooth stack.
So from what I've seen on the block diagram of the chip, one of the chip that supports it, yeah, apparently is connected directly to the Bluetooth radio and then back into the matrix. So I presume they're gonna run the Bluetooth stack on it. Not sure, but
Or I guess you can run anything.
definitely.
Yeah, and so the PR was merged, and it has a bunch of quirks to make sure that, because basically the ARM core is responsible for launching and booting the RISC-V core. So there's a bunch of stuff to enable that. But yeah, it's cool. It's I guess there's more and more of those SoCs,
Multi-core.
right? Yeah.
Yeah, it's probably something. Yeah, if you're in the field, it's probably something you want to be familiar with because there's a lot of them around.
Yep.
And it's good to have a build back to the previous point. It's good to have a RTOS with a build system and infrastructure that allows you to deal with this kind of situation, right? Having multiple builds, having to start a secondary core, having an IPC
Yes.
framework, stuff like that. So good stuff.
What else? A PR, a reasonably small PR, but it's sort of a continuation of some of the work done in the previous release with the CPU frequency subsystem and like all those low-level hooks and primitives to adjust at runtime based on policies to change the frequency of the system. And so there's now a new API to basically like inform and be informed whenever the system timer clock rate changes. So it's I would encourage people interested in those kind of scenarios to check all this PR in particular and all the PRs in flight around the frequency subsystem, because vendors are driving a lot of changes and innovation in that area. So it's cool stuff. And interesting and hairy problems as well, right? Because when you start like changing the clock at runtime, like what is your wall time? What is your uptime? Like it's like I'm sure. It can get really complex.
And back to subsystem, there's been a change in the Bluetooth stack, which I do not know much about. You want to speak about that one?
Yes. We said we would cover a bunch of networking and Bluetooth news. Well, this one I think will be interesting only for maybe a few select individuals, but the generic access service from the Bluetooth stack has been extracted, and like there's been some refactoring, making it easier to potentially tweak and replace the way the very basic GATT server works. So I think it was worth mentioning, and I don't know a lot more than you, Fabio, but at least you will have the link, folks, in the notes if you care about this. This was also an excuse to mention another service that's now available, which is the standard elapsed time service from the Bluetooth SIG and the Bluetooth specification. So yeah, it's a really simple one, but it exposes you want to expose basically a tick counter or like a time to the outside world. So that's useful for medical devices and whatnot. So it's there. It's actually something that I had on my radar this week, because I was thinking again, I guess, that I really would want Zephyr to have more end-to-end, really like significant code samples. And I was like, okay, the first one I think I want to add is some kind of weather station. And so something that an app basically that shows you how to deal with sensor data, how to potentially expose data over Bluetooth. Should Bluetooth be available on your board? Like there is a service to expose environmental sensor data. There is a service to expose the clock, maybe expose a way to reconfigure the clock over Bluetooth. Add also some RTC API usage in the code sample, a display, of course, potentially things like the state machine framework to show how the UI, like how you would design your UI in a way where, okay, if this sensor becomes unresponsive, this part of the UI is going to go in a different state, sort of thing. Potentially integration with battery, charger, fuel gauge. I mean, I think, yeah, I would like to see this.
Yeah, I have my traffic light demo, which is interesting, right? You have
Send the PR, send the PR.
Wi-Fi credentials,
Yeah.
DNS, HTTP query, and JSON.
Yeah, those kind of things. And so, folks listening, I think you might have some ideas as well on such application. But I think at least having one would be really good, and something that also works well in a simulated environment, like the weather station. Sure, ideally you run it on a real device with maybe an e-ink display and actual sensors and the battery, etc. But it would also be nice if you can like, fully run it on native sim and have a way to test it. And so we would basically demonstrate quite a lot of useful APIs and features this way. So yeah, long story short, should we add some sort of weather station sample in Zephyr? There's typically lots of Bluetooth services that could be exercised, including this new elapsed time service.
Yeah. Well, right now you can take your end-to-end project and push it on GitHub, and
yeah, that too.
I don't know, maybe we should just give visibility to like my demo is on GitHub, but nobody knows, right?
Yeah, put a link in the show notes. People will check it out. With that, I think so. I thought we were short on news, but we actually
And yet,
we had quite a bit to cover. As a way to wrap up, well, Embedded World is coming up, but I will not mention it again. You know by now. Hope to see many of you there. There is also about a month from now a meetup in Rennes, France, which I think I mentioned before, but now it's like fully announced. It's going to be on March the 26th, and they are
you're
still
going?
looking for. I am going, and there's a CFP open, so there's a few slots available still. If you want to talk about something, present something, make sure to fill the Google form. You will find the link in the notes. You will find also in the notes the link to our Discord channel. Make sure to subscribe, give us some feedback on whichever platform you're listening us on. And with that, I think we will be back next week. Thanks. Bye.
Bye.